Hello, you tens. We've looked at a lot of graphs. I thought we'd go through a few recaps of what each graph looks like and the basic properties of them. This is an optional video. Watch on. It's stolen from some other PowerPoint, but I still think it's quite good. Firstly, linear graphs. In the form y equals ax plus b, you've also seen it as mx plus c, where here the first number, the coefficient of x, is the gradient, second number, y-intercept. When a is greater than 0, you would expect positive slope, -0, negative slope. This line is also known as a straight line. Don't ask me why that guy's face is there. Quadratics. When the leading coefficient a is greater than 0, smiley, frowny, also known as a parabola, nose but weird face. Good. Reciprocal functions. When a is greater than 0, you would expect it to operate in the first and third quadrants. First quadrant, third quadrant. Same here, except when a is less than 0, second and fourth. Note the asymptotes. Here they're both x equals 0, y equals 0. Exponential. Y equals abx. Goes up there. Now, a is always the y-intercept because when b is to the power of 0, it becomes 1, therefore giving us y equals a. Equation of a circle. With radius 5 is going to be x squared plus y squared equals 25. That is the general form equation of a circle. Given pictures of circles, you should be able to put them in the equation form quite quickly, especially if they're centered on the origin. Yes, that was fun, wasn't it? Back. Now, matching graphs. I'm going to throw a few up there that you don't need to know. So cubics, you won't need to know yet. Sine graph, you don't need to know. Cubic, you don't need to know. And, well, the last one's a Batman function, which is fun, but let's just throw that up there. We'll look at that in a sec. Now, first one, consider A. It is quadratic in shape, parabolic. It's crossing at -2 and 1. So we're looking for something that has x-intercepts of -2 and 1, and is a quadratic. Well, from our remaining options, we have that as a quadratic, but it's got a negative leading coefficient, so we rule it out. That one. Good. This here, negative leading coefficient quadratic, is the only one left. Note, without a middle single x term, like this one, it's automatically going to be centered on the y-axis. Curve perfectly about the y-axis. This one here, with that single x term, can move it off the y-axis. Alright, F. Looking at F. Hyperbolic, existing in the first and third quadrant. That one. Hyperbolic, in the second and fourth quadrant. That one. Exponential. There's only one exponential down there. And linear. Nice. Just for interest, that's the Batman function, which is pretty cool. Alright, now, here. Find estimates of the solutions of the following equations. X squared plus x minus 12 equals 5. This here is the graph of x squared plus x minus 12. And if we put in the line 5, that is the horizontal line along here. Now, you can do this perfectly in your calculator by plotting a horizontal line and finding where these two lines meet, which is going to be there and there. But right now, we can estimate where they meet by going there and dropping straight down, which is what? 3.6 and minus 4.7. Minus 4.6. Alright. Finding constants of y equals a times bx. Given 2 points on an exponential curve, you should be able to sub in to find the equation. So we can sub in when x equals 1, y equals 7, when x equals 3, y equals 175. Now, click to reveal the answer. Don't worry about all of that. There is an algebraic way to do it. And if you rewind the video a bit, you can see their algebraic solution, especially if you look it down there. But all that matters for us right now is to substitute those values in and get two equations. Two equations, two unknowns, put them in your calculator, solve. So write solve, first equation, and second equation, comma k, comma a, it will come out perfectly. And do the same with these. You can pause the video now, have a shot of them, I'll reveal the answer in 3, 2, 1, now, and now. Same again. Pause the video, have a shot at these. I'll reveal the answer in 3, 2, 1, 0. Thus ends the slideshow. Thank you very much.